Hello Dragons, this is Mr. Mahalik. This is video 8 of Unit 1 and it's going to be over inequalities. Just a brief review over the 4 inequality symbols that you have seen for quite a while. Make sure you are familiar with them. Now remember, whenever we talk about the word solution or solutions, you might even see the word solution set. Those are numbers or values that make equations and inequalities true. Solutions make things true. Please remember that because you're going to see those in the instructions. So the big question is, are we going to remember when do we reverse or flip the inequality symbol? Some of you may remember, some of you may not. Let's just do a quick review on what you can and can't do and how it affects this. I'm going to do the same inequality. 20 is greater than 18, and that is true. I'm going to do it 4 different times, okay? Do I get a true statement if I add a number to both sides? Is 22 greater than 20? Yes, it is. So I don't have to reverse the symbol when I add. What about if I subtract a number from both sides? I get 18 is greater than 16. Guess what? That is also true. So adding and subtracting on both sides of an inequality statement, I don't have to flip the inequality symbol. But look what happens if I multiply both sides by a -1. I now get a -20 is greater than a -18. And if you remember your number line, the number that's farther to the right is greater. So this guy is now greater than -20. And this is saying -20 is greater than -18. This is now false. So when I multiply by a negative, in order to make it true, what I'm going to have to do is I'm going to have to come over here and reverse the symbol. Instead of greater than, I get less than, and now it's saying that -20 is less than a -18. Now it's true after I flip the symbol. So I had, because when I multiplied by a negative, my greater than symbol had to become a less than symbol in order to keep the statement true. Same thing over here if I divide by a negative. The statement is true, but if I divide by a -2, I get -10 is greater than -9. -9 is there, -10 is there, -9 is greater. So this is false, but in order to make the statement true, all I need to do is flip or reverse the inequality sign, and now it is true. So what can we surmise from this quick example here? You flip or reverse the inequality symbol when you multiply or divide by a negative. So let's look at some of the problems that you're going to see possibly in this unit test. Now, if you notice in the instructions, it says which is a part of the solution set. So we're looking for which of these numbers make this inequality true. Now you could take each of these numbers and plug it in for n and just see which one makes a true statement. But we're going to use our skills that we've been learning in previous videos. We don't have any parentheses, so we don't need to distribute, but we do have alike terms over here. So -5 plus 2 is a -3 in front of the variable n. Combining does not change the symbol. So I now have this statement. And now, at this particular point, I am multiplying the variable by a negative. The opposite of multiplying by a negative is dividing by a negative. Uh-oh. What did we say previously? We said that if we multiply or divide by a negative, we're going to flip the inequality symbol. So that's what I'm going to do. Because I divided by a negative, I'm going to take this less than symbol and I'm now going to change it to a greater than. -3 over itself is 1 in front of the n, and then a +3 divided by a -3 is -1. Now, if you prefer, once you're finished and you have a single variable on one side of the inequality, you can rewrite this by calling halftime and having the two sides switch sides. So if I put the n on the left-hand side and the -1 on the right-hand side, the symbol that's pointing towards the n over here has to point towards the n over here. So either one of these is correct. I like to have my variable first. So here we go. Is -10 less than -1? And yes, it is. And I have all of these numbers wrong.